Hello everyone, welcome back to my channel. Today we are going to start new topic, total differential equations. First we shall see the definition, then we solve some problems on this total differential equation. Definition: the equation of the form p dx plus q dy plus r dz equals to 0, where p, q and r are functions of x, y and z, is called a total differential equation. So that is, any equation, if it is of this form, then this function is this equation is called as the total differential equation. So now, before going to solve this equation, we have to check whether this function this equation is integrable or not. So that we have a condition for the integrability of the given total differential equation. Condition for integrability: the necessary and sufficient condition for integrability of differential equation, that is p dx plus q dy plus r dz equals to 0, where p, q and r functions of x, y and z, is, the condition is that p bracket dou q divided by dou z minus dou r divided by dou y plus q of dou r divided by dou x minus dou p divided by dou z plus r of dou p divided by dou y minus dou q divided by dou x equals to 0. If this condition is satisfied, then the given differential equation is said to be integrable. That is, it satisfies the condition for integrability. Okay. So now, in the same way, we have the condition for exactness of the given equation. So that is, the given differential equation is said to be exact if it satisfies this condition, that is, dou p divided by dou y is equals to dou q by dou x, dou q by dou z is equals to dou r divided by dou y, and dou r divided by dou x equals to dou p divided by dou z. If these are true, then we say that the given differential equation is exact differential equation. Now we shall see the solution for the total differential equation. The total differential equation can be solved in three ways. First is the method of inspection, and another one is the treating one of the variable as the constant, and the third one is the method of grouping. So in these three ways we can solve the given differential equation, but in this section we are going to solve by using the method of treating one variable as a constant, and another method, that is the method of grouping. So let us see some examples on the method of treating one of the variable as a constant. So let us take an example. Verify the condition for integrability and solve 3x square dx plus 3y square dy minus x cube plus y cube plus e raised to 2z into dz equals to 0. Solution: here p is given by 3x square, that is coefficient of this dx, and q equals to 3y square, and r equals to minus x cube plus y cube plus e raised to 2z. Now we find partial derivative of this dou p, that is p, q and r. Okay, first we find dou p divided by dou y equals to 3x square. 3x square differentiation is equals to, with respect to y, is 0. In the same way, dou p divided by dou z is equals to, we get 0. Okay, because it doesn't contain any z terms. And next, dou q divided by dou x value is equals to 3y square. 3y square with respect to x is 0, and similarly dou q divided by dou z value is equals to 0. You remember one thing, so if you write p, q, r order wise, then we get and x, y, z, then no need to find this dou p by dou x. Simply we have to find p, that is partial derivative of this p with respect to y and z. In the same way, partial derivative of this q with respect to x and z. It is not necessary to find this dou q by dou y. In the same way, dou r, that is the partial derivative of r, is with respect to x and y. So that we have to find dou r divided by dou x equals to, with respect to x we get minus x cube, differentiation is 3x square. Similarly, dou r divided by dou y value, with respect to y its differentiation is 3y square. Okay, so these are the partial derivative. Now we write the condition for integrability. That is, we have the condition for integrability is p into dou q divided by, so we have to write p into dou q divided by dou z, dou r divided by dou y, dou q divided by dou z minus dou r divided by dou y. In the same way, plus next after p we get in the cyclic manner q into, after q we get r, so dou r divided by dou x minus next we get dou p divided by dou z. Similarly, next term is r into dou p divided by dou y minus dou q divided by dou x equals to 0. Now we substitute all these derivatives values in this condition for integrability. So that is, p is equals to 3x square dou q by dou z. Dou q by dou z value is 0 minus dou r by dou y is minus 3x square plus q value is 3y square, dou r by dou x value is minus 3y square minus dou p by dou z. Dou p by dou z value is equals to 0 plus r value is minus x cube minus y cube plus, that is minus e raised to 2z into, we get dou p by dou y value is 0 and dou q by dou x value is also equals to 0, so that we get 0 minus 0. So we have to check whether it is equals to 0 or not. It implies that 3x square minus into minus we get plus 3 into 3 we get, sorry, it is, here we have to substitute dou r by dou y value which is equals to 3y square and this one is 3x square. So multiplying this we get 3 into 3 9 x square into y square, here plus into minus minus 3 into 3 9 again x square into y square, so that we get 0. So thus it implies that the condition for integrability is satisfied. That means the given total differential equation can be integrable. Okay, now we integrate the given total differential equation by using the method of treating one of the variable as constant. So in this case we treat the z as constant, that is z we treat as constant. Okay, so first let us consider the given equation. Given equation is 3x square dx plus 3y square dy minus x cube plus y cube plus e raised to 2z into dz equals to 0. Consider this as equation 1. Now treating, you can treat any one of this variable, either x, y, that is x, y, z, whatever, all of these three you can consider any one of the variable as constant. Okay, so in this case almost we choose z is equals to 0. You can choose x is also equals to, sorry, not 0, z equals to constant, or you can choose x equals to constant or y equals to constant. But in this example we consider treating z as constant c. Okay, so when you treat this z as constant, definitely its derivative dz will be 0, because differentiation of constant is equals to 0. So substituting in the given equation 1, we get 3x square dx plus 3y square dy is equals to, we get this term becomes 0, so that we get 0. Now integrating this, we get 3x cube divided by 3 plus 3y cube divided by 3 is equals to, here we get integration constant, that is constant of the integration c, and this constant of the integration we treat this as a function of z. So we have to consider this as f of z. 3 get cancels. Here we mention that here the integration constant, that is the integration constant is treated as function of z. So as in the starting we have taken z as a constant, so that this integration constant is treated as a function of z. Okay, so further simplifying this one, we get x cube plus y cube is equals to f of z. Consider this as equation 2, or you may write this as x cube plus y cube minus f of z is equals to 0. Now on differentiating this totally with respect to x, y and z, so differentiating totally with respect to x, y and z, we get, so remember that we are differentiating this totally, that means each term is differentiated with respect to x, y and z. So this is called the total differentiation. We are totally differentiating. Okay, so after differentiating, as it contains only x terms, so that we differentiate with respect to x. On differentiating we get 3x square and x differentiation is dx. Next come to the second term, so it contains only y term, so its differentiation is 3y square dy, minus it contains only z term, so its differentiation is f dash of z into dz equals to 0. Consider this as equation 3. So if you can compare this equation 3 with the given equation 1, that is this equation 1, so you can observe that these two equations are same. So 3x square dx, here also we have 3x square dx, 3y square dy, 3y square, sorry, it is 3y square dy. So comparing the terms, we get f dash of z value is equals to this one. So that comparing with equation 1, that is given equation, you can write given. Okay, so comparing with given equation, we get f dash of z value is equals to x cube plus y cube plus e raised to 2z. Okay, so this can be further written as f dash of z can be written as differentiation of z, that is differentiation of f with respect to z, right, and x cube plus y cube. You can observe that this x cube plus y cube is nothing but function of z. So from the equation 2 we can write x cube plus y cube as f of z plus e raised to 2z as it is. This is from the equation 2. So observe all the steps carefully. So f dash of z is written as df divided by dz, that is differentiation of f with respect to z, and x cube plus y cube from the equation 2 we can replace it by f of z, and e raised to 2z is as it is. Okay, or this can be further written as df divided by dz minus f of z, or simply you can write f also, f of z is equals to e raised to 2z. Now you can observe this equation. This is similar to the linear differential equation, that is, this is of the form first order linear differential equation. So this can be solved by using linear differential equation method. So that is, we have to first integrating factor, that is if, then we write the solution. So before going to solve this, just we recall the linear differential equation formula. So that is the equation of the form dy divided by dx plus p into y equals to q is called linear differential equation of first order, and its solution is given by y into if equals to integration of q into if dx plus c. Here if is integrating factor and its value is given by e raised to integration of p dx. So as here we are differentiating with respect to x, so therefore here we have considered x, but in this case it is the differentiation of the function f with respect to z. So that we have to replace this y by f. Okay, so for this particular, the solution will be f into integrating factor equals to integration of q integrating factor. So instead of dx we will have dz plus c, and also if value will be integration e raised to p, as it is in the place of dx we will have dz. Okay, because this LD is with that, that is, it is a function of f with respect to that is, this is the derivative of f with respect to z. Okay, by using this formula we can solve this function, that is this equation easily. So we have written this is the linear differential equation of first order. So therefore here first we have to write, that is comparing this with the standard linear differential equation, the p term will be coefficient of this f. So therefore here p value is -1 and q value is, that is RHS side of this equation is e raised to 2z. Okay, so now we find if integrating factor is equals to e raised to integration p dx. Okay, in this case we have dz, so e raised to -1 dz. Integrating we get minus z integration is, that is 1 integration is z, so that we get e raised to minus z. Thus the solution is, so y, because it is the function of f, so sorry, this LDE contains the f terms, so therefore we have to write f into if equals to integration of q into if into dz plus c. F value, sorry, so here first we keep this f as it is. If value is e raised to minus z integration q value. So q value is, in this case q value is e raised to 2z into, again if value is e raised to minus z dz plus c. Further simplifying we get f of e raised to minus z equals to, simplifying the powers of e, we get e raised to z dz plus c. On integrating we get f into e raised to minus z is equals to e raised to z integration is e raised to z plus c, or we write f value is equals to e raised to z plus c divided by e raised to minus z, or it can be written as e raised to z plus z is equals to e raised to 2z plus, we write c into, taking this to the numerator we get e raised to z. So this is f equals to, thus the final solution, that is the general solution is, we substitute f value from the equation 2 Okay, f value is nothing but it is x cube plus y cube equals to e raised to 2z plus c into e raised to z, since from equation 2. So this is the required solution of the given total differential equation. So it is quite lengthy, but in the simple way I explain all the steps. First we have to check the condition for integrability. Okay, the second step is treat one of the variable as constant, okay, or treat z is equals to constant. Then the third step is integrate, okay, and fourth step is differentiate totally. Then in the fifth step we have to compare with equation or given equation, okay. Then we get f value, okay, that is equation, one of the equation in terms of f, or in the different cases we get different form of the equation. In this particular example we got this f in terms of LDE, okay. So it was linear differential equation of first order, so therefore this can be solved by using LDE method, or sometimes we get the simple equation which can be easily integrated. So simply we have to solve for f, okay. After comparing with the given equation we have to solve for f. It may be the LDE method or simple integration method, okay. So by using both. So in the next example we find that is we solve f in the simple integration method, okay, by the simple integration method. Second example, z square dx plus z square minus 2yz dy plus 2y square minus yz minus zx into dz equals to 0. So here also first we have to check the condition for integrability, then we go for the solution. So the condition for integrability you check by yourself, okay, or we only solve this one, okay. See here, first we write the given equation, z square dx so this is the given equation. So here comparing with the standard total differential equation, here p value is equals to z square, q value is equals to z square minus 2yz, and r value is equals to 2y square minus yz minus zx, okay. Now differentiating this p with respect to y, we get 0 dou p by dou z equals to 2z, dou q divided by dou x equals to z square differentiation is equals to 0, and it doesn't contains any x terms, so therefore its differentiation is 0. Dou q divided by dou z, z square differentiation 2z minus 2y is constant, z differentiation 1, and dou r divided by dou x with respect to x, so these two does not contains x terms, so that minus z, and dou r divided by dou y, so 2y square differentiation is 2 into 2 4y minus here z we take outside y differentiation 1, but it does not contains y terms, therefore its differentiation 0. So dou r by dou y value is 4y minus z. Now we substitute in the condition for integrability. The condition for integrability is given by p into dou q divided by dou z minus dou r divided by dou y plus q into dou r divided by dou x minus dou p divided by dou z. plus r into dou p divided by dou y minus dou q divided by dou x equals to 0. Okay, and substituting LHS side, p value is z square dou q by dou z. Dou q by dou z value is 2z minus 2y minus dou r by dou y. Dou r by dou r value is 4y minus z. Minus into minus we get plus z. Plus dou q value is z square minus 2y into z. Dou r by dou x. Dou r by dou x value is minus z. Dou p by dou z. Dou p by dou z is minus, that is 2z, plus r value we substitute 4y minus z. Next dou p by dou y. Dou p by dou y value is 0 minus dou q by dou x is also equals to 0. So simplifying this one, we get, here we get 2z minus z equals to, 2z plus z is equals to 3z minus 2y into 4y is equals to 6y. So multiplying this with this bracket, we get z square into 3z is equals to, we get 3z cube minus 2 plus 4 equals to 6 y into z square. Here we get minus 3z. Multiplying with this bracket, we get 3z into z cube. So sign is minus 3z cube minus into minus plus 2yz into 3z, 2 into 3 6y z square. These two get cancels, that is 3z cube minus 3z cube cancels. Similarly this also cancels, we get 0. Hence the condition for integrability satisfied. Okay, now we go for the solution. Here also we use the same method, that is treating one of the variable as constant. In this example also we treat z as constant. So this is our given equation 1. Now treating z as constant, we get dz equals to 0. So that given equation becomes z square dx plus z square minus 2yz into dy equals to 0. Consider this as equation 2. Now integrate, we get, so here you can observe that here dx is there but it does not contain x terms, so z square we take outside. One integration is x plus z square into dy. Z square we take outside, dy integration is y minus 2z is taken outside, y integration is y square divided by 2 equals to one integration constant that we treat as, again it is treated as, z is treated as constant, so therefore the integration constant is treated as function of z. We write here the constant of integration is treated as function of z. So we get, simplifying, we get z square x, or you can write z square x, z can be taken common, we get x plus y Here 2 get cancels, we get minus zy square minus f of z equals to 0. Okay, or before this step we can write z square x, that is z square x plus y minus zy square value is equals to f of z, that is function value. Okay, so this is also important, so we consider this as equation 3. Now differentiating this totally, so after in the first step we treat z as constant. Okay, after this step we integrate. Okay, so here we have used integrating. After integration we have to differentiate totally. Differentiate totally with respect to x, y, z. So remember that we are differentiating totally. So differentiating totally, each term is treated as a function. So as it contains x, y, z terms, so we have to integrate with respect to x, y and z also. So z square taken outside, that is we have to write UV rule here. Z square as it is, this bracket differentiation is dx plus dy. Now we write x plus y, z square differentiation is 2z into z minus zy square. So z is taken out square, y square differentiation is 2y into dy minus y square as it is, z differentiation is dz minus, it contains only z terms, so therefore we differentiate with respect to z only. Its differentiation is f dash of z into dz equals to 0. So or it can be further written as z square into dx plus z square into dy plus 2z into x dz plus 2yz into dz minus 2zy dy minus y square dz minus f dash of z into dz equals to 0. Now we group all the dx terms one side, dy terms one side and dz terms one side. So z square dx plus z square dy, here it contains minus 2zy. So grouping these y terms one side, we get z square minus 2zy into dy. Now z terms are grouped, okay, one side, that is 2zx plus 2yz, then minus y square into f dash of z. Okay, plus we write 2zx plus 2zy minus y square minus f dash of z into dz equals to 0. Consider this as equation 4. Now comparing this equation with the given equation 1. So given equation 1 is this one. Okay, so you can observe that in the place of z square dx we have z square dx, in the place of z square minus 2zy, here also we have z square minus 2zy into dy. So this gives the coefficient of dz. So the coefficient of dz is this one. Therefore comparing this with given equation, we get this all terms gives the coefficient of dz. Okay, that is the comparing the coefficient of dz, we get 2zx plus 2zy minus y square minus f dash of z is equals to, in the given equation the coefficient of dz is this one, that is it is 2y square minus yz minus zx. Okay, so solving this one, 2zx minus, you bring this side, 2zx minus zx equals to 3zx, 2zy plus yz is equals to plus 3yz, and 2y square, if you take this side you will get minus 3y square, and equals to, we send this side f dash of z, or it can be further written as f dash of z means it is, or we write first one step, f dash of z is equals to, in these all this we can take 3 outside, 3xz plus yz minus y square. So we are taking 3 common here, or you can observe that xz plus yz minus y square. So in the equation 3, z square x plus y minus zy square is given by function value. So that here you can observe that here we have xz, but here we have z square. So therefore we multiply this equation by z square, or from equation 3 we can write z square x plus y minus zy square equals to f of z, or we can write f of z divided by, or z we take common from these two terms, we get z into x plus y, or we can write zx plus zy minus y square. On taking z common from these two terms we get zx plus zy minus y square, or f of z divided by z can be written as zx plus zy minus y square. So now we substitute this value, its value, by f of z. Therefore it can be written as f dash of z can be written as 3 into f of z divided by z. So here I have mentioned the reason. Okay, or f dash of z is nothing but df divided by dz equals to 3f by z. F of z is nothing but f, or we can write it as df divided by f 3 into 3 by z into dz. We send this dz to RHS side. Then integrating, so you can observe that it doesn't take LD form. Simply we can integrate this one. Integrating we get df by f, we get log f plus dz by z, 3 log z, plus integration constant we take as log c, or it can be written as log f. So it can be written as log, this take to the z power z cube, log c, or log m plus log n value is equals to log of m into n. So c into z cube. Taking anti-log on both sides we get f value is equals to c into z cube. But f value is nothing but this one, z into zx plus zy minus y square. We substitute that value, that is from the equation 3, f value is given by z square into x plus y minus y square z equals to cz cube. So this is from equation 3. So this gives the general solution. This is required solution. Okay, like this you have to solve the given differential equations. So in the next video we solve by the method of grouping.